Hello, Algebra 2 students. So last time we learned how to solve a system of equations using the graphing method. But that's not always the most convenient because sometimes you will end up with a situation where the y-intercept will be negative 3/4. And then it's hard to plot a point that's negative 3/4 way down and then use the slope. It's just not always the best method. So there's other methods and there are algebraic methods. The first one is called the substitution method. And so that will be the 3.2a notes. And then 3.2b notes will be the second method, and it is known as elimination. So we'll talk about substitution. So the steps for substitution may sound confusing, and they kind of are until you actually do the problem, but I'll read through the steps. So you have two equations. So if you look at example one down below, you have the top equation, that's equation number one, and the bottom one, the equation number two. So in step one, you solve one of those equations for either x or y. You want to choose the one that looks easy. And when I say the one that looks easy, it's the one where um, there's a one or a negative one in front of the x or y. So I'll jot that down. All right, so I guess what I'm going to write over here is negative 1 or 1 in front of the variable. You don't want to choose something with like a 3 or a negative 3 or 7 or something other than 1 or negative 1 in front of the variable. Step 2, substitute the resulting expression into the other equation, the one that you did not use, and solve for that variable. Step 3, substitute your answer from step 2 into either original equation and solve for the remaining variable. And step 4, check your solution algebraically in both of the original equations to make sure it is a solution. So, probably doesn't make sense until we actually do the problem. So, as we're doing each problem, I will tell you what step I'm doing, and we go through the steps in order. So, step number 1, we are going to pick one of those two equations, the one that looks easiest and that has a 1 in front of it. And so if you look at the top equation, there's a 3 in front of the x, there's a 2 in front of the y. So we don't want that equation. The bottom equation, there's a negative 2 in front of the x and a 1 in front of the y. So we want the bottom equation. So we want to solve this bottom equation for y because it's the only one that has a 1 in front of it. So we want to add 2x to both sides because we want y by itself. And we are left with y equals 2x plus 4. And that's step 1. We solved one of those equations for x or y. Well, we chose y because y was the easier variable. Okay, now what do we do with that equation? So here's what I tell students. Since y is a variable on the left side, make a little bubble around the right side. And that is your resulting expression. That is the resulting expression that you are going to put into the second equation for y. Because we solve for y, we are going to replace this y with 2x plus 4. So we are going to do that. So we are going to have 3x plus, remember there's still a 2 in front first. You're only replacing the y with the bubble. So replace the bubble with another bubble or parentheses. Close it, and that's equal to 1. And now this is really easy. We did this in chapter 1. You solve the equation for x. So work out the entire left side. Use the distributive property here. 2 times 2x is 4x. 2 times 4 is 8. And please don't say 2 times 4 is 6. I mean, those kind of mistakes are things that you're going to make, and then that's on you. So 3x plus 4x is 7x plus 8 equals 1. And make sure your x looks like an x and not a y. Subtract 8 on both sides. 7x equals negative 7. Divide by 7. X equals negative 1. Well, we found x, and now we need to find y. So here's what we're doing in step 3. So in step 3, we are going to substitute that answer, that x equals negative 1, into either of these two equations right here. Either one. So you get to pick which one. And I think the bottom, well, we could just put in the top one because there's no negative. So let's just do that. So 3, so take this and replace it into one of the original equations. So I'm going to replace it in the top one. So 3 times -1 plus 2y equals 1. And you did all this in Algebra 1. It was chapter 7, by the way. Okay, add 3 to both sides. 2y equals 4. Divide by 2. Divide by 2. Y equals 2. Now, what's the best way to write your answer? Well, in alphabetical order because it's x and y. So x is -1 and y is 2. If you were to graph it, you would have graphed each line individually, and the intersection point would have been -1, comma 2. This is just another way to do this problem. So now we're going to go back and check our answer. We won't check in every problem, but we will for this one. So we are going to check this. I already circled it, but you know what? We shouldn't have. So we're going to check it. So CK for check. 3 times, remember, x is -1 and y was +2. -3 plus 4 equals 1. -3 plus 4 is 1, and 1 equals 1. Okay, now let's check in the bottom equation. -2, x is -1, plus 2 equals 4. Oops, negative times negative is a positive. And 4 does equal 4. They both check. That's when I should have boxed in my answer, but that's okay. Okay, let's look at example number 2. Solve the system using the substitution method. So this particular equation, we can tell automatically the top equation is one we don't want to use because x has a -2 in front of it and y has a 2. The bottom equation, both x and y have a -1. Well, one variable is already on the left side, so that's the variable we want to use. So we should solve for x. First thing we should do is put a 1 here in front, 1 there in front, and now let's get x, or now since x is already solved for other than the -1, you can divide everything by -1 because we want a positive x. So that's x equals y plus 4. Okay, and now we want to bubble that in because we have a variable by itself on the left side. And notice the variable we have on the left side is x. That's what we're going to replace the top equation with. So we're going to replace that x with the y plus 4. So -2 times y plus 4 plus 2y equals -4. Distribute, so -2y, a -2 times 4 is -8, plus 2y equals -4. We want to combine like terms before we do anything else because these are alike. -2y plus 2y is 0y, or it's just, they cancel. So just cross them out. So we're left with -8 is equal to -4. That is a false statement. We know the number -8 can never equal the number -4. So this is false, but that's not your solution. The solution is no solution because there is no intersection point. And you cannot check a no solution, so it works out great that we're done with this problem. Okay, and then example 3, our last one, solving the system using the substitution method. So top equation, I automatically spy that the y has a 1 in front of it, so we want to solve for y. Bottom equation, I'm not even looking at because I see too many numbers there. So we want to subtract 2x. Y equals, now do we need to write the x first? This time I'm going to write the 5 first because we're not graphing it, so it doesn't matter if we use y equals mx plus b. I want the positive number first. Now I'm going to bubble this in. The bubble really helps because then you know that the bubble needs to be replaced. And we are going to replace the bottom equation because that's the one we have not used for y. So we're going to take that and replace it right there. So we have -6x minus 3 times our bubble, which is 5 minus 2x, close it, and then that is equal to negative 15. Negative 6x. Now let's be careful here. We have so many negatives. Negative 3 times 5 is negative 15. And a negative times a negative is positive. If you make mistakes like that and you come up with an ugly answer, you should probably think that you did something wrong. But sometimes you can have ugly answers. Negative 6x plus 6x is 0. They cancel. So we're left with negative 15 equals negative 15. And that is definitely true. Same numbers on both sides. So this is infinitely many solutions. And if you're lazy like me, you could just put infinite. So infinitely many solutions. And we can check this one. We can put in any number for x and y, and it would work, but there's no point in checking it. So I'm not going to waste your time on that one. Okay, our last question for section 3.2a is a word problem, and you will have those. And for me, word problems are the most fun as far as systems of equations go because they make sense and they're useful. You and your sister decide to combine your weekly overtime earnings to buy a birthday gift for your mother. How sweet of you. Your overtime rate is $18 per hour. So your overtime rate is $18 per hour. And your sister's overtime rate is $24 per hour. Notice the per hour. So let's circle that. The total amount earned for the gift was $288. So total, there we go. If you worked 2 more hours of overtime than your sister, oops, how many overtime hours did each of you work? So let's just come up with some real life variables. So we're not using X and Y. So Y can be your overtime hours. Because it's asking us in the bottom, the last sentence or the last question, how many overtime hours did each of you work? So your variables are going to represent overtime hours. And S can be your sisters. Okay, I'm going to make my brace because I'm going to put my system in the braces. You don't have to, but I'm going to. So notice your rate is $18 per hour. So it'd be 18 times Y because if you worked 1 hour, it'd be 1 times 18. If you worked 2, it'd be 2 times 18 and so on. Plus your sister's rate was $24 per hour and use your sister's variable. And the grand total, so this is talking about hours, 18 times the number of your hours plus 24 times the number of your sister's hour. And total hours worked were, or I'm sorry, the total amount, sorry. So this is $18 times Y plus $24 times S equals $288 because the top equation is going to deal with money. The bottom equation is going to deal with the time. So if you worked 2 more hours, so you 2 more hours than your sister means S plus 2 because whatever your sister worked plus 2 more. So if sister worked 5, you would work 5 plus 2, which is 7. If sister worked 9, then 9 plus 2, 11. So make sure that it makes sense. So for this particular one, we wrote our system. And notice the bottom equation already has the variable solved for. So you can just make your bubble. Only make your bubble if this left side has a 1 in front of it and only a 1 in front of it. So that's the only time you put a bubble. I have students making bubbles for no reason when there shouldn't be, when there's like a 6 in front of the Y. So just don't do that. Okay, now that you made your bubble, you want to take that and you're going to replace it for Y because you solved for Y. So 18 times S plus 2 plus 24S equals 288. 18s plus 36. Make sure your s does not look like a 5. Plus 24s equals 288. Okay, I'm going to combine my 18s plus 24s, and that would be 42s plus 36 equals 288. Subtract 36 on both sides. 42s equals 252. Use a calculator when numbers get too big for you and you're not wasting your time dividing large numbers. 42 goes into 252 exactly 6 times. But let's see what the question's asking. How many overtime hours did each of you work? So your sister works 6 hours because this is your sister. Okay, and then you can go back and plug in this right here. So you work 6 plus 2. Now we don't put the answer is 6 comma 8. This is a real life application problem. And in a real life application problem, you write a sentence or a phrase to answer the question. So you can say you worked 8 hours. Oops, 8 overtime hours. Let me just put it there. And your sister. So order doesn't matter in the real life problems. And your sister worked 6 overtime hours. This is not allowed because I don't know what 6 and 8 mean. That doesn't tell me anything in this particular problem. So this is your final answer, right? And that is it for the substitution method. Next, we will talk about the elimination method.